This video describes how energy is required for and produced by chemical reactions. There are a number of factors that influence the rate of reaction. It is helpful to think about reactants as particles that are together in a vessel. Any factor that increases the number of collisions between these particles will increase the rate of reaction. Increasing temperature will speed up particles. If the particles are moving more quickly, there will be more collisions taking place between the particles. Increasing pressure will also result in more collisions between particles and an increased rate of reaction. Some factors will affect the likelihood of a reaction once the particles do collide. As surface area of particles increases, so too does the rate of reaction. Some reactants are more reactive, and so they have an increased rate of reaction. A catalyst can also increase the reaction rate. When we use collisions of particles to describe, explain, and predict chemical reactions, we call this collision reaction theory. The main ideas of this theory include that a chemical sample consists of entities, which may be atoms, ions, or molecules, that are in constant random motion. For a reaction to take place, the reactants need to collide. For a collision to be effective, there needs to be enough energy and the particles need to be oriented correctly. If the collision isn't effective, the particles will just bounce off each other. This diagram shows an effective collision. There is a correct orientation and sufficient energy for a reaction to occur. This diagram shows an ineffective collision. The molecules have the wrong orientation for a reaction to take place. The two particles will bounce off of each other and will remain in motion. Throughout our next two lessons, we will be exploring why some chemicals react faster than others and why reactions require energy to occur. For any reaction to take place, an energy barrier must be overcome. This minimum amount of required energy is called the activation energy. This energy can come from heat, light, or electricity. Although this reaction is exothermic, there is an amount of energy required to initiate the reaction. This is the activation energy. This diagram shows the energy pathway for a reaction. The energy pathway is the relative potential energy as the chemical systems move from reactants to an activated complex, and finally the products. The activated complex is what is formed when the reactants collide. You can recognize the point in the energy pathway where the activated complex is formed because it is where the potential energy is the highest. The energy pathway shows the entire path of the reaction. The first step involves the molecules moving towards each other. As they get closer together, they begin to slow down as a result of repulsion forces. When they slow down, the kinetic energy decreases, and some of this energy is converted to potential energy. If there is enough kinetic energy, or if the particles are moving fast enough, they can get close enough to form an activated complex. The activated complex is an intermediate form of the two combined reactants that occurs at the maximum potential energy point. In the end, the products of the reaction are pushed apart by repulsive forces. Please complete the September 24th quiz.